Hey everyone. Alright, in today's video we are going to learn about compound events, and the first compound event we're going to talk about is independent events. Your objective: I will be able to calculate the probability of compound independent events. So last video we learned about simple events, and in a simple event only one action occurs. So in a compound event there is going to be more than one action. So you may be asked to find the probability of landing on tails when you flip a coin and rolling a 4 when you roll a die. So in that situation, two actions are happening. Now for independent events, the occurrence of one event does not affect the probability of the occurrence of another event. So let's say that you flip a coin and then roll a die. It does not matter what that coin lands on. That is in no way going to affect what happens when you roll the die. They are completely separate. They do not affect one another. Now, if you are doing something like drawing something out of a bag, so your action has to do with the same object each time, the key word is replacement. Okay, so if your total is staying the same, your probability is not affected. And you'll see what I mean by that in a moment. So whenever we find compound probability, we find the probability of each event happening and then multiply them. So if there are two actions occurring, we should have two probabilities, and then we will multiply them together to get the final probability. Alright, so here's example 1. We have a bunch of cards here. Now it says, what is the probability of selecting a 4, then a 7, when you replace the first card after you select it? Now this is one of those situations where we see the word replace, so it is an independent event. And the reason it's independent is because I could select a card and then record the probability, put it back, and notice how everything stays the same. So if I replace a card after I've drawn it, I haven't done anything to affect the next probability because everything stayed exactly the same. So let's find the probability of selecting a 4. Well, as we can see here, there are 3 4s on this page, and there are 12 total cards. So that would be 3 out of 12. And of course, we want to simplify this, and that would reduce to 1/4. So there is a 1 in 4 chance that if we selected a card, it would be a 4. So let's say that we did do that. We selected a card and we happened to get a 4. So then we're going to put the card back, and notice how everything looks exactly the same. So that's why it does not affect our next probability. So now we want to find the probability of drawing a 7. Well, there is only one 7 out of 12 cards. So the probability is 1/12. And now we've got two different probabilities that we have found. So we've got to find one probability for the entire situation. So we're going to multiply the probabilities together. So the probability of drawing a 4 was 1/4, and the probability of drawing a 7 was 1/12. And remember, when we multiply fractions, multiply the numerators, and then multiply the denominators. So there's a 1 in 48 chance that we would draw a 4 and a 7 afterwards. Alright, example 2. What is the probability of flipping tails on a coin and rolling a number greater than 4 on a number cube? Alright, so let's find the probability of flipping tails. Well, on a coin, one side has tails and there are 2 total sides, so the probability of that happening is 1/2. So let's find now the probability of rolling a number greater than 4 on a number cube. Keep in mind these are independent because what happens with the coin in no way affects what is going to happen when you roll the die. So on a typical number cube or die, there is 5 and 6. Those are the sides greater than 4. So that's 2 sides that are greater than 4 out of 6 total sides. And we need to make sure we reduce that to 1/3. So now we've got our 2 events and our 2 probabilities. So we're going to multiply those together, and find the final probability. 1 times 1 is 1, and 2 times 3 is 6. So there is a 1 in 6 chance that you would flip tails and then roll a number greater than 4. Okay, now it is time for you to try. So you are trying to find the probability of selecting a 3 and then an even number. And remember, this has replacement, so when you find your second probability, everything is the same in regards to how many cards are there total. All right, make sure you show all of your work and answer your question on Educanon, and bring your notes to class with you next class day, and have a good day.